Hey guys, it's Mike here. Today we're going to talk about AWS Database Specialty Certification Exam. This is a very rewarding and valuable certification if you want to pursue database specialty, or if you are an architect or software engineer who's interested in knowing more about databases and different type of architecture in database world. So of course this is not an easy exam. As we know, specialty exams definitely require a lot of preparation, and in this video I'm going to do my best to guide you guys and walk you through all these steps and things you need to know in order to become successful in this exam. In the first section of this video, I'm going to talk about the preparation cost of the exam and how to schedule it. And in the second part, I'm going to talk about the technology side of it and how to prepare and what to expect in this certification exam. So the exam costs $300. If you are new to AWS, I definitely recommend that you take first cloud practitioner, or maybe solutions architect, associate, or developer before taking the specialty exam, because specialty exams, again, they do require good foundation and solid foundation in AWS in order to become successful. So once you take that, let's say you take one of the associate one or cloud practitioner, and then once you pass the exam, you will get a voucher 50% that you can use towards this exam. The cost is $300 again, but with 50%, after passing one of those associate exams, you can get 50% discount, which is a great value. So the exam is 180 minutes. You will see around 65 questions. That puts you between 2-3 minutes. And it's really hard sometimes to read those long questions, to understand the challenge, and to come up with the right answer. So if English is not your first language, you have the option to add another 30 minutes and request that through, for example, Pearson VUE when you're scheduling your exam. I personally choose online proctor. You just go to your AWS certification account and then select, for example, Pearson VUE, and then go through the setup, pay, and that will be the entire process for just signing up for the exam. You can reschedule the exam up to 3 times. I say commit to it, schedule it. For example, let's say I want to spend 2 months, 3 months studying for this database specialty exam, or a month, whatever you're comfortable with. And then as you're approaching the exam date, if you feel like you're not prepared, just postpone it for another month. So let's talk about the exam strategy. When you start the exam, after checking in, you will see the questions. Question number 1, let's say it's a very hard and long question. So what I recommend always, you just skip that question, flag it, and come back to it later. One thing I want to mention, don't get stuck on the time, because some people, they just keep checking the time and they lose focus. That's not a good thing. So have some sort of reference. For example, if there are 65 questions, I know, let's say around halfway, I should have, for example, 100 minutes. Have those references and check the timer, like just after 5-10 questions. Like, don't check it constantly, and while you're reading the question, don't look at that timer. Don't drink too much water and coffee about 3 hours before the exam. Get very good sleep at night, at least 9-10 hours, so your brain is ready for the exam. So the first thing I want to talk about is the difference between a SQL and NoSQL database. We do have a lot of options to design our database, to store our data based on the use case. So make sure you have a very clear understanding about SQL database and NoSQL database. You got to know that SQL databases support ACID, and NoSQL databases, in some cases, they do support. DynamoDB recently added support for ACID. So make sure you understand the difference between hosting your database on EC2 and RDS. So managed services like RDS, they're great because Amazon basically patches them, takes care of them, and does all the things that you don't have to deal with. So it reduces your overhead cost, and of course you don't require to bring someone who's comfortable with running databases, basically. But sometimes companies and projects, they do require access to underlying operating system where you host your database. You want to have access to extra things that RDS doesn't provide. You have to understand, when you are using RDS, you're not going to be able to SSH into the instance. It's out of the reach. You cannot log into underlying operating system. On the other side, RDS comes with automatic patching, backups. So you have to think, when you're architecting your database, that do I have to keep my database in EC2 or no? Can I just use managed services? So always you have to prefer the managed service, because it's definitely reliable. All the security patches and everything, Amazon will take care of those issues for you. So you got to know in RDS you have what database vendors you have, for example, Oracle, PostgreSQL, MySQL, MariaDB, and Microsoft SQL Server. Just remember, all the types and different vendors that are available. RDS has storage. Auto scaling, so you don't have to be worried about provisioning the right capacity for your database, and that happens with zero downtime. Remember that when you use RDS, the storage scaling happens with zero downtime. Know the difference between parameter groups and option groups. If you want to fine tune your database, you use option group and parameter group to set up your specific database vendor for your use case. Right, but remember that parameter group requires manual reboots. So if you change a configuration, for example, I don't know, in SSL setup, then you have to do manual reboot. It won't happen even if you schedule a restart on a maintenance window. So you have to manually reboot your database. In option group, there are more features related to specific database vendor that you can fine tune your database. So remember about the AWS security model. We do have a shared responsibility in security in AWS. So Amazon makes sure the cloud is secure, right, in general. But you are in charge of controlling traffic and securing your database. Let's say if you assign a right security group to your database and open it to the entire world, and your database gets compromised, and you cannot blame anyone but yourself because you opened it up to the world. So this is the responsibility model that you need to understand. Amazon will patch the operating system so no one can actually take advantage of security vulnerabilities that are known in the industry. However, if you, for example, open a port, or if you set up your database, or if you make it publicly available, these are the settings that, it's basically your responsibility. So make sure you have a very clear understanding, about the database security, RDS security, and what's on the customer side and what's on AWS side. You can use IAM authentication, which is cool, in MySQL and PostgreSQL. These two database vendors, they do allow using IAM for authentication mechanism. So secret managers is one thing that's always we use with databases, right? So let's say you want to have a username password for your database, and your application requires access to database. So you don't want to hard code those values, username passwords in your application, or put it in a config file somewhere in your application and goes to, for example, GitHub or a code repository, and that's a security vulnerability. So what you want to do, you always want to take advantage of a secret manager, where you basically store your databases and it automatically integrates with database, and it does have rotation. So it rotates the password. That's the key. It rotates the password for you. You could technically save those in SSM parameter store as a secret string, but remember, the only way you can rotate the password is only secret manager. So RDS does have automatic backups, encryption at rest, and encryption in transit are supported. It does integrate really well with CloudWatch, but in some questions you might see, hey, we do need to access more a matrix in CloudWatch, and they're not accessible. So make sure you understand the difference between the normal CloudWatch logs matrix and enhanced one, because usually enhanced ones provide more insight. When you want to understand the behavior of your database. Learn how to create snapshot. The RDS does automatic, backups, but when you take snapshots, those are snapshots. First of all, they're manual, and when you take snapshot, basically you are creating a manual backup that later you could restore them and you could use them, because when you remove a database, all automatic backups will be deleted. So you need to understand that. So if you don't take a snapshot of your database and you delete your database and you see all those backups, but after deleting your database, you will realize that you just lost your database with all the backups. So in order to do this properly, you have to take manual snapshots. One thing I want to talk about is multi-AZ RDS. Basically, let's say you have two availability zones. When we launch our RDS, we'll say, hey, yes, we want to use both, for example, two availability zones for our database, right? And the reason we want to do that is not because of the performance, right, issue. And this does not help your application to become faster because you have two. No, this is only for a high availability, right? Let's say you lose one AZ, one database goes down, RDS automatically fails over to the other one. But while you're operating normally, you're always talking to one database, and the second one, which is the secondary database, is just idle, is sitting there. It doesn't do anything. You cannot access to it even if you want to. So you're only always talking to your database that's living in one AZ. But as soon as that database goes down or that AZ goes down, AWS automatically fails over to the secondary AZ, so your application can stay up and running. So remember, in production level, it's always recommended that we keep databases in multi AZ zone, and that happens synchronously. So let's say I write a record in a database, right, and it goes to the database right now, and I have a synchronous replication with another database like RDS multi-AZ. So what happens basically, I'm writing into both databases at the same time, right? This is technically means synchronous replication when you write immediately in both resources. Of course, there's a cost to it, but that's the cost you're paying to have that highly available operation. So this is synchronous. Now, if you have for example, asynchronous, let's say we create read replicas for our database, right? Because RDS supports read replicas where you can offload all the traffic that's coming only for reading operation. You can offload those, requests to your read replicas. So we create read replicas in RDS in order to offload from main database. So let's say we only send requests that are writing to our database to main database, but if someone is querying our database and just wants to read information, we'll just send the traffic to read replicas. Note the limitation between read replica and the main one. Study those and the limits, how many read replicas you can have. But the idea is the relationship between read replica and the main database is asynchronous, meaning the main database, as soon as it writes the record in a table, it sends the asynchronous request to read replica, meaning it sends the request, but it doesn't wait for the response to come back. It doesn't happen immediately. So there might be a delay between the read replica and the main one. So if you are immediately writing into main database and reading from read replica, that record might not be there. So you have to wait, I don't know, for example, a second or two to make sure the asynchronous replication happens. But multi-AZ RDS comes with synchronous replication. So when the application fails, when something goes down, your main database automatically goes to the second AZ, which does have all the information that you're expecting. So one thing I want you guys to review, if you already know, you can skip this section, is RTO and RPO. So recovery time objective, it's a business requirement, right? Or RPO, a recovery point objective. So when you discuss with client, let's say, or you want to build a system for your company, or for your consultant, you want to go help a customer to build a database, you need to ask about RTO and RPO. So if you're designing a database, okay, RTO, let's say we go down right now. Can you afford being down for a day? They're like, no, we can only be down, for example, for an hour. So the amount or the time frame that you're allowed to be down, that's called RTO. Let's say you can be down for an hour. It's okay. That's fine. Sometimes they say there's no downtime. So always to have a better RPO, you can now completely relate to it. You have to spend a lot of money. If your RTO is zero, meaning you're not gonna tolerate any outages. So if your RTO is 2 days, meaning you have 2 days in order to come back and become available, which is more relaxed, and of course you can spend less money in order to provide that business requirement. RPO is the amount of data that you're willing to lose, right? Let's say my RPO is 5 minutes. If I lose 5 minutes of my data, that's completely fine. I can go ahead and recover them or do other things in order to make my database up to date. So make sure you understand the difference between RTO and RPO and how they relate to cost, because it's always about the efficient design when you're architecting your system. And the last thing about RDS I want to talk about is performance insight. So when you create database and let's say your customers are complaining about the speed of your database and they want you to investigate that issue. So what you want to do, you can use a tool called Performance Insight, where it shows all the queries and the runtimes, and you can investigate. The next topic is Aurora. And Aurora is basically MySQL and PostgreSQL that's basically designed by Amazon Web Services. They're relational databases, but they're compatible with MySQL and Postgres database. So the reason you want to use Aurora, first of all, it's by Amazon Web Services. It's very efficient and cost effective when you compare to other database vendors. It does come with 15 replicas, which only is accessible in Aurora, meaning you can offload more reads to your read replicas. Aurora is faster than MySQL 5 times and 3 times faster than PostgreSQL. So if you have a compatible workload on MySQL or PostgreSQL, definitely consider migrating your data to Aurora. The architecture in Aurora, it's very interesting. It actually copies your data, keeps a copy of your data in 6 different locations in 3 different AZs. So if one availability zone goes down, the other ones are still available and you can recover. So it does the failover automatically within the region. So it does have built-in auto scaling for storage, for compute, and of course auto scaling. So Aurora, remember, does have a serverless model, which it's a managed one. Of course, you don't have to provision any capacity, anything. And when the request comes in, database starts, and then if there's nothing, there's a cooldown period and shuts down the database. So it's very good for test and dev environment where you want to test your database. So it supports SSL, encryption at rest and transit. It integrates really well with Amazon CloudWatch. It does have automatic backups, snapshots, and one more thing, which is called Backtrack. Backtrack is only supported for MySQL, and what it means, when we usually restore a database from a snapshot, or we want to restore our backup, what happens is RDS creates a new instance. So remember, this doesn't happen in place. It creates a new instance and restores our database. However, in the Backtrack, which is an option for MySQL, you can basically double click and go back. In Aurora failover, it's a very important topic in the exam and real world. So when the main instance goes down, if you have a read replica, Aurora automatically promotes that read replica to a main database. By the way, remember, you can make and force the read replica to accept writes. So this is something that you can configure. But in this scenario, as we're talking about failover, this happens automatically within the region. So if Aurora sees any failure, automatically promotes the read replica and redirects traffic to the new promoted database. So remember, you need to understand and read everything about failover and how Aurora handles this failover within the region. So one thing I want to talk about is you can load data from S3 to Aurora. That's something really nice, that you can technically load your database from S3 in Aurora. The last thing about Aurora is invoking a Lambda function. You will see, use cases in real life and of course exam that it will the use case is basically invoking a Lambda function from database. So Aurora does provide that functionality, which is great. DynamoDB and Redshift. I've talked about DynamoDB and Redshift in full detail in my other video, which is data analytics certification exam. I explained everything that you need to know. If you haven't watched it and you want to take this database specialty, I definitely recommend go watch that video as well, because it will definitely help you, get more points. So we know that DynamoDB, it's NoSQL database where we can store, unstructured and semi-structured data. It's single millisecond latency. It's super fast NoSQL database at scale. It does have a lot of use cases in gaming, in online voting, in high traffic operation, like for example e-commerce website. So these are the use cases for DynamoDB. So make sure you read about the write capacity and read capacity and the calculation between partitioning and read and write capacity. I talked about all those in my other video. Make sure you have a very clear understanding about the consistency model of DynamoDB, and you know the difference between eventual consistency and strong consistency, and how does this affect the write capacity and read capacity, because it does change if you change the consistency model. So about partitioning, and having a hot partition as a result of a bad design in DynamoDB is a very common thing that you see also in real life. So let's say you create a database, DynamoDB, it's a voting system, and two of your candidates are so famous, so all the requests are only going to two partition. So those two partition, they become bottleneck, and you look at your table, you say, hey, I do have enough capacity, but you have to remember that capacity, it's basically split between the partitions that you have in your DynamoDB, and it becomes a provision throughput error. So in order to avoid that, you have to create some sort of a random mechanism and randomness, introduce it to your record. So when you send your data to DynamoDB, it randomly goes to different partition, and it doesn't make a hot partition. So read about the partitioning capacity. It does have, DynamoDB does have automatic auto scaling. Read about the errors like 500 error, 400 error, what they mean, and why you might get those error. Local secondary indexes and global secondary indexes, know the difference between them and how they impact the query process in your database. So global tables are actually very useful, and they're my favorite. Let's say you have a application that serves all the users around the globe. You can use global tables. For example, let's say you have one table in in US West, and one table you have in US East. It does have cross-region replication. As soon as you write the data in one of your tables, automatically it becomes available in the other one. And behind the scenes, what happens, DynamoDB has something called streams. As soon as you change something, it creates a stream. It creates the event, so you know what changed. So basically, cross-region replication works off of the same technology. The stream creates that replication request and goes to another region. So DynamoDB streams, as I just explained, make sure you read about them, local secondary indexes and global secondary indexes, and know the write capacity and read capacity for global secondary indexes are addition to your tables. So these are the things that you really need to understand about DynamoDB. About adaptive capacity and on-demand and provision capacity. So know the difference between, for example, provision capacity and on-demand model. So these are the things for a fine-grained control on your database. It's good to know that IAM, you can do that using IAM, and you can control at the fine grain at the item level. One more thing about DynamoDB, you can use something called DAX in front of DynamoDB, which makes it even faster. It's already a single-digit millisecond, that makes it even faster. So it's a cache system in front of your DynamoDB. If you have a very, very popular item, you can put that item in DAX in front of DynamoDB and just read it directly from that. So in DAX, you have two types. One is item cache, one is query cache. So you can put the query or you can put the item. And it's recommended to serve that in 3 nodes, which basically provides high availability. So consistency model, write capacity, read capacity, and the relationship between the partitions and how to prevent a hot partition in your DynamoDB. These are all the things pretty much, plus streams that you need to know about DynamoDB. The next topic is also Redshift. Redshift is a data warehouse. I talked about it in details in my data analytics certification exam, but remember the sort key and the type of the distribution, all, even, and key. They're very, very important, and you need to understand them really well. Redshift Spectrum is basically, it's a great feature where you don't have to load, for example, historical data in your Redshift database. You can just use Spectrum, Redshift Spectrum, where you can collect your data, you can query your data from S3 without loading to Redshift, and you can avoid extra cost and time, and just get the result, for example, and then merge that result with your current result, with your current information. So let's say I have information, sales information, I want to analyze those for the year 2020, but I do need access to the last 10 years. So the technique that you want to use, always use Redshift Spectrum in order to merge that with your existing data without loading that in your Redshift cluster. So know how to copy your snapshot to another region in Redshift, read about it. Encryption and rest and in transit is supported in Redshift. One thing you need to remember is Redshift it operates in an availability zone. So if you have an outage in an AZ, you're going to lose that cluster. So you can definitely launch a new cluster from a snapshot that you've created, but it's not a multi-AZ service. Two more things about Redshift. Concurrency scaling is just for heavy read databases. Let's say you have a lot of, users that are reading data from your Redshift and they're experimenting a little bit like a lag. What you can do, you can use concurrency scaling. And the last thing about it is workload management, where you can basically prioritize your queries. Let's say you have a long running query that's kind of preventing other short running queries to get executed. So what you can do with workload management, you can prioritize and make your data warehouse more efficient. But definitely if you have a local on-prem data warehouse system, you can consider Redshift, as it's very, very cost effective and super fast. So CloudFormation is the next topic, which is a very, very important in real life. Of course, we have better technologies in infrastructure as code, like AWS CDK, Terraform. So make sure in CloudFormation you know how mappings work, right, and how to read from a map. For example, let's say you have a AMI ID and the region, and how to read that from a map. Make sure you understand how parameters work and how you can pass values. Make sure how you can run your database in CloudFormation, because if you make a mistake, you're going to delete your database and you're gonna have issues. So secret manager is the best way, as I mentioned, to pass your secrets to to your application and access the database. So make sure you understand the relationship between CloudFormation, how to create a database, and how to read secrets from secret manager. So functions in CloudFormation, nested stacks, how to create nested stacks, what is change set, and how to deploy resources in a target account. Let's say you're running in a tools account and you want to deploy something in your production account. So stack sets, this is the technology that you use, and make sure you read about all the concepts about infrastructure as code and CloudFormation. Outputs, basically it's the output of a stack that you can pass and import in another stack. So CloudFormation, definitely infrastructure as code. In real life, you definitely need if you are somehow working in AWS area. So DMS database migration service, I do have another video that I completely have a hands-on experience for DMS. If you watch that, I'll promise you will nail every single question in DMS. But technically, the idea behind DMS is you have a source and destination database where you create two endpoints, one for source, one for destination, and you have a replication instance that copies data from source to destination. Now, if you are using SQL Server on both sides, you just migrate the database information, right? It's easy. Now let's say you want to migrate your Oracle database that costs a lot of money to Amazon Aurora, PostgreSQL compatible. What you want to do, you want to run a tool called SCT, which is a schema conversion tool. It does create a assessment report. It's a great, amazing tool where you can basically convert your database data type, things that are different based on the engine. Once you have that enabled and you figured out all the schema conversion, then the second stage will be basically migration, which is a DMS. So if you are going from if you are going from MySQL to MySQL, you don't need SCT. Remember, you just need database migration service. If you are going from one vendor to a different vendor, you need to run the SCT and perform and make the data work with the new model before running your database migration service. That's something about DMS that I wanted to mention. The next topic is Elastic Cache. It's in-memory data store. We have two types in AWS. One is Memcached and one is Redis. Redis. Redis is used for more real-life applications, and Memcached is good for testing an idea or maybe a simple application because it's just a key value, storage, in-memory storage. And if something happens, an outage happens, you're going to lose your data in your Memcached because it does not support, backups. On the other side, Redis does support complex data types, which probably we want in real life applications. You can basically create a backup. You can export your data to S3. So it comes with a lot of more features. So read about Redis, and the questions are obvious. Usually in real life application, again, we use Redis as opposed to Memcached. The next topic is Elasticsearch. It's basically the same ELK stack, Elasticsearch, Kibana, and Logstash that if you're familiar with. It's basically Elasticsearch for indexing and searching, Kibana for visualization. Logstash is basically just log delivery and log ingestion mechanism. Like if you know how Kinesis work or how CloudWatch works, it's the same concept, right? So it's basically ELK on AWS Cloud, right? So let's say you want to have an application that you want to constantly in real time monitor all the 400 errors that's happening on your website. You can use this ELK and stream data to Elasticsearch and do real-time analysis on your, for example, website traffic. Remember, it does support multi-AZ, and it integrates with CloudWatch really, really well. The next service is called Amazon Keyspaces. Keyspaces is basically good for Cassandra workloads. So if you see Cassandra workloads, Amazon Keyspaces is a service that you want to think of. It's a NoSQL, open source database, very strong for heavy workloads. It does support encryption at rest and in transit. If you want to migrate your, let's say, local Cassandra workload to AWS, you export your data to CSV from your, let's say, Cassandra workload. And then using copy command, you can copy that into, for example, Amazon Keyspaces. So make sure you understand the consistency model of Keyspaces, but in general, you might see the questions that, or real life scenarios that you want to convert your, migrate your on-prem Cassandra workload to AWS, and the way you do it using Amazon Keyspaces. So Amazon Time Stream is another service that basically is a database, it's a managed database that it's good for time series. For example, think of AWS config. So it tracks everything over time. So it's the same concept. If you have a scenario that you want to, track things over time, Amazon Time Stream is the type of the database you want to use for this use case. The next one is Amazon QLDB. Is basically the ledger database. You have one major ledger and which is immutable, you cannot change it, and then you have multiple tables that you can write information into and connect it to that ledger basically. But remember, this is a centralized database. This is not decentralized like blockchain, but it's a kind of similar idea. It uses a language called PartyQL. So this is how you write basically queries. So as I mentioned, you have journal and you have table, but you have a mechanism that you can validate your data. So data verification, there's a section that you can see the hash function and you can validate if someone has changed it or not. At this time, it doesn't support backup restore, but it does have a streaming functionality. Let's say if I write something to my QLDB for my ledger workload, I can get an event triggered so I can do something else with it. Let's say I can create a Lambda function that goes and updates a record in DynamoDB, for example, right? So but it does support ACID, which is good for transactional workload. So the next one is Amazon Neptune. That's used for graph databases, highly connected data sets. Like think of Facebook and think of a fraud detection website where you need to find relationship between entities and people. For example, this person is brother to the other one, and the other one works for this company. So what's the relationship? So as soon as you hear about highly connected data set, think of Amazon Neptune. It does have a workbench where you can basically write your queries. It does support encryption at rest and transit, SSL. It's same architecture as Aurora. It does have 6 copies across 3 AZs, which is great. It does have automatic failover, backup restore, replication, replication up to 15. You have cloning supported. Cloning is a technique that's good for testers and developers. Let's say you want to have a copy of your production workload. The answer is cloning your database. The cloning your database, it doesn't affect the main data, but at the same time, it doesn't copy your data to a new storage. So you can save on cost and of course time, but immediately you can provide data set for your developers and testers if you need to. So you can clone the database. When you restore your Amazon Neptune database, it creates a new instance. So remember, restoring is always goes to a new instance. And of course, you have a bulk loading, functionality where you can load off all the information, directly to your Amazon Neptune. Alright guys, I hope you enjoyed this video. We talked about all the services in AWS database specialty exam and of course in real life. So hopefully it was useful and I hope to see you guys soon. Bye.